And we are continuing on. So now we're going to do some examples of how to find an x value if we have the probability of something and that something is normal. So just like when we were finding probability, when we're finding the data value or the x value, we're going to follow a 4-step process. And we're going to do this for every single problem that we see. So the process is we're going to start by drawing our normal curve. That gets a step all to itself. Then we're going to shade the approximate area on the curve that we have the probability for. Then we're going to use Excel and we're going to use the function norm.s.inv to find the z-score. And then finally we're going to use the z-score to solve for x. So we're going to be looking at this example. I believe this is the same example as we had previously. So we have female heights that are normally distributed with a mean of 65 inches and a standard deviation of 3.5 inches. So just like I did before, I'm going to go ahead and highlight or underline the important things. So it's normally distributed, a mean of 65, and a standard deviation of 3.5. Those are the important pieces of information that we've been given so far. So now the first problem says, find the height so that the area to the left is 0.4139. So we are finding a height. We are not finding a probability. Find the height. Height is our variable. It is what our x values represent. So that's what tells me that I'm trying to kind of work backwards and find the height. And then we're told that the area to the left, so that's going to tell me where to shade my curve. And that area to the left is 0.4139. That's my probability. Okay, the probability to the left is 0.4139. So we're going to start our process. First thing we need to do is draw our curve. Oopsies. Let's try that again. My curves are getting wonky, y'all. Okay, that's a little bit better. All right, so there is my curve. Go ahead and put the mean, which has a z-score of 0 in the middle. And then we need to go ahead and shade. So to shade our curve, I need to identify, do I have the area to the right, to the left, or do I have an area in between? So here we have the area to the left. And then I also need to identify how much of that area am I going to shade. Remember, the entire area underneath this curve is equal to 1. We have 0.4139. So we've got a little less than half the curve that we know the probability for. So if we're looking for the area to the left, that means that that's the section that gets shaded. So this is kind of like a less than problem. Okay, excuse me, hang on one second. So the area to the left of this unknown z-score is 0.4139. So the area less than some value is 0.4139. So the other thing that I want to remember when I'm looking at these types of problems is that the mean is cutting this distribution in half, meaning 50% of the curve is below the mean, 50% of the curve is above the mean. So we're looking at the area to the left, and that's a little under 50%. So when I'm shading, I'm going to start shading somewhere over here on the left-hand side of my curve. Maybe not even that far. Okay, maybe like here. And then I want the area here. Okay, this area that I just colored in is equal to 0.4139, or about 41% of my curve is what I shaded. And it's the area to the left of this unknown z-score. Another way I like to think of this, I'm going to undo what I just did. Another thing that I like to do when I'm doing these problems is if I know the area less than the value, or the area to the left, I'm going to start on the left-hand side of my curve. And I'm going to shade until I've shaded about 41-42% of the curve, which is going to be about there-ish. Okay, to me that looks like it's roughly 41% of my curve. And then wherever I stopped shading, that's where my z-score is. And I don't know what that z-score is right now. I need to go find it. So that's how I think about where am I shading when I'm looking at these problems. If I know the area to the left, I'm going to start on the far left and shade until I've shaded about 41% of my curve, because the area is equal to 0.4139. If we had the area to the right, then I would have started on the right-hand side of the curve and shaded until I got to about 41% of the curve shaded. I know I can't go past the middle, because if I shade all the way up to this middle value, this 0 here, then I would have shaded 50% of my curve. So I know I can't go past the 0. Okay. So now that we've drawn our curve and we've shaded the area that we're looking for, we're going to go into Excel and we're going to use the function norm.s.inverse to find the z-score that corresponds with this area. So if I switch to Excel, okay, we've got all the stuff from last time. I'm going to go to a new sheet. Okay, so now I'm in Excel, so I'm going to come in here and I'm going to do equals norm.s.inverse. And this function only needs one thing. The only thing it needs is the area we've been given, 0.4139. If I hit enter, that result is the z-score where the area less than this z-score is the 0.4139 that I entered. Now, if I do this again, just so you guys can see, norm.s.inv, which is short for inverse, because we're doing the inverse or the opposite of what we were doing before. And I did 0.4139, because that's what we have. Just like when we were finding the probabilities with Excel, Excel is going to assume that whatever probability or area you put into this inverse statement, it's going to assume that this is the area to the left of the z-score that you want to find. So if it is the area to the right, we're going to have to do a little more work. Luckily for us with this first example, we have the area to the left. Oh, it's almost like I did that on purpose. I did. So we get a z-score of negative 0.21575. Numbers, they're getting flipped around in my brain. So coming back here, let me write this down real quick, except for I don't want to write it there because I have one more thing I have to do. Negative 0.2175. I think that was right. I'm going to have to go back. 2175. Okay. Boom. There we go. Okay. So the area to the left of negative 0.2175 is 0.4139. So now this value that I just found, this right here, this is a z-score. This is not a height. You cannot have a negative height. This is a z-score. So this means that my answer is going to be less than the mean. And the mean is 65. And I know it's going to be less than the mean because the z-score is negative, meaning this person's height was below the mean. So the last thing we're going to do is solve for that person's height. So you take the z-score times the standard deviation, and then you add the mean. So negative 2175 times 3.5 plus 65 is 64.2388 inches. So a person that is 64.2388 inches tall is taller than 41.39% of people. Or the probability of getting somebody who is less than 64.2388 inches tall is 0.4139. Okay? So there's one example. So now let's look at another one. So how tall is a woman who is in the 80th percentile? So what is important here? Well, we've got how tall is a woman, not what is the probability. So how tall is a woman? And this woman is in the 80th percentile. So we need to recall, what does that mean for someone to be in the 80th percentile? If you're in the 80th percentile, that means you are taller than 80% of women. Or the area to the left is 0.8. Okay, if you're taller than 80% of women, that means 80% of women are less than your height. So the area to the left of you is 0.8. So whenever we see percentile, that is telling us that we have an area to the left, and that area is equal to whatever the numerical value for the percentile is as a decimal. So 80th percentile means 80% less than, so we have an area to the left of 0.8. Oh, this copied over weird. We should have had more room. You should have more room in your notes. That's okay. All right, so let's go through the process again. So first thing we're going to do is draw the curve. Oh gosh. Better-ish, I suppose. Okay, we have 0 here, cutting it in half for us. And now we want to shade. Step 2 is to shade to the left 80%. So again, when I see I've got the area to the left, which I know because this is a percentile, I'm going to start on the left-hand side, and I'm going to keep shading until I've shaded roughly 80% of my curve. I'm going to have to go past the mean, because if I shade only to the mean, then I've only gotten 50% of my curve. Because recall, the mean splits it in half, meaning 50% below, 50% above. So here is what I think is roughly 80% of my curve. And wherever I stop shading is where that unknown z-score is that I need to go find here in step 3. Okay. So norm.s.inverse, the only thing we're going to have to enter is the area to the left. And I already know the area to the left because percentile means to the left. So the area to the left of my unknown z-score is 0.8. So now I'm going to go back to Excel. Oops, where did Excel go? There it is. Okay, go into a new box. And let's do norm.s.inverse. Don't forget the equal sign. 0.8. And we hit enter. Boom, 0.8416. That is the z-score, so that the area to the left of that z-score is equal to 0.8. So 0.8416. Okay, and again, this value that I just found is the z-score. It is not the height of the woman. There's one more step to find her height, which is to take the z-score that I just found, multiply it by the standard deviation, and then add the mean. And now since our z-score is positive, because we had to shade going all the way past the mean, our answer should be larger than the mean. And I got 67.9456. So a woman who is just shy of 68 inches tall, which is 5'8", would be in the 80th percentile for her height, meaning she's taller than 80% of women. So there's another example of a different way to word a question that is giving you the area to the left. Okay, so the last one, which printed kind of funny, I'm going to do it down in this bottom section. Find the height that has an area to the right equal to 0.3214. So now, oh, I just did yellow. It really doesn't matter, but I'm trying to change things up. So now find the height. So we're not finding a probability, we're finding a height. Height is our x. We have an area to the right of 0.3214. So now this is where we're going to see us have to do a little bit more work to find this probability, because now we have the area to the, or this height, because now we have the area to the right instead of the area to the left. So let's get in there and start this process. So the first thing we do is draw our curve. My curves just keep getting worse. Okay, and then label the middle. And now we have the area to the right. And we want to shade approximately 32% of our curve. So I have the area to the right, so I'm going to start on the right and I'm going to shade moving towards the center until I've shaded roughly 32%, because the area is 0.3214. And I'm going to say that's probably about right there-ish, kind of. It's not an exact science how much we shade, but it is exact that we don't want to go past the mean, because we only have 32% of the curve on the right, not more than 50. So z equals some value. So now, because I started shading on the right and I moved towards the center, now this area that I've shaded is the area to the right of my unknown z-score. So I've drawn my curve, I've shaded to the right, so now I'm going to go into Excel. I'm going to go to norm.s.dist, but remember what I said, Excel assumes that you are entering the area to the left of your unknown z-score. We have the area to the right. So we have 0.3214 on the right. In order for Excel to give us the right value here, we need to find the area to the left. We need to find this area in pink. This is what I want to enter into Excel, because it's the area to the left of my unknown z-score. So there are two ways you could do this. You could find the area to the left separately. So I would find the area to the left of my unknown z-score by doing 1 minus 0.3214. Or you can just plug that in to this norm.s. Oops, that should be inverse. Ah! Sorry if I confused y'all when I wrote that down. This should be norm.s.inverse. Okay, so norm.s.inverse assumes that we or the norm.s.inverse wants the area to the left. We know the area to the right. So we are going to take 1 minus the area to the left to find the area to the right. And we can plug that directly into Excel. Or you could find it separately and you would get 0.4796. No, 0.6796, I believe. I'm doing it in my head, so you guys know I'm not good at subtraction. Okay, so we're going to plug this into Excel, and the answer is going to be the z-score that corresponds to this area. So, coming back into Excel, going into a new column, norm.s.inverse, 1 minus 0.3214. And we hit enter. And we get 0.4638. I'm going to write that down, but then I'm going to come back to Excel and show you guys something. Okay, 0.4638. So now, coming back to Excel, if you do this in Excel, and you do 0.3214 minus 1 instead of 1 minus 0.3214, you're going to get an error message. Because if you do 0.3214 minus 1, that is a negative number. And Excel knows that you're trying to put in a probability, and probability cannot be negative. So you have to remember that it's 1 minus the area to the left, not the other way around. Cool? Cool. All right, so 0.4638 is our z-score, which I already wrote down. Okay, it's positive, which is good because we stopped shading on the right-hand side of 0, so that means we didn't mess up our shading. And so finally, same as we've been doing, we're going to plug this into the equation to solve for x. 0.4638 times 3.5 plus 65 is 66.6233. And that is inches. I forgot my units on the last one. Okay. So if you are 66.6233 inches tall, roughly 32% of people are taller than you. Or the probability of selecting someone that is 66.6233 inches tall or more is 0.3214. And those are some examples of how to find an x value, a data value, a height, if we've been given a probability. Now there's one more example, but I'm making that a separate video because it's a little bit more complicated than these. Okay? So if you have the area to the left, draw your curve, shade starting from the left, plug that area into the norm.s.inverse to get the z-score, and then solve for x. Percentile means area to the left. If you've been given the area to the right, you need to start shading on the right and then find the complement to get the area to the left, because that's what you need to plug into norm.s.inverse. So here are 3 examples of how to do this, and then there's one more video which will show us what if we have the area in the middle of a distribution.